So yeah, Ricardo, stage is yours.
So thank you, Ingo. Thank you for the possibility to talk here. Can you hear me well?
Yes.
Perfect. This is partly based on an article that published in Communications by CM in June of 2019 about search, about web biases. So I will use the web as an example for going through this road of different biases. But before I start, let's have the same understanding of what is bias. I think we can have like three definitions that are basically similar, but apply to different contexts. So you have the classical statistical bias, where you have a systematic deviation from a reference value. Some problem that you can find is that we don't know what is the right reference value. So for example, which should be the right percentage of women in this talk? I don't know. Maybe it should be 50%, but maybe not. Also, you have cultural bias that depends on our education background. It's encoded in the language. So language is a powerful channel for bias. Many languages have some words, other languages don't have some words, and so on. And then you have cognitive bias, which is basically the most dangerous one. For example, confirmation bias, where you see something aligned with your beliefs and then you believe it. And this is the main fuel for fake news. And of those are more than 100 different cognitive biases, and you can find this codex in the web. So what are the motivations for this presentation? And interesting that Jeremy mentioned this. So we optimize for engagement, and to do that, we optimize using implicit user feedback. So any interaction with the user means something that we can use to improve the system, and we'll get back to that later in the talk. However, all the interaction can be done only on things that are shown to us. So basically, the system is in some sense writing its own future, and we can only click on those things. So we'll get back to that, because I think today that's the worst bias we have. And then, of course, you can have something like self-fulfilled prophecies or suboptimal solutions, not only because filter bubble for users, but also because we have filter bubbles or echo chambers for systems. And I will finish with that in my presentation. And sometimes we can even be competing with ourselves, especially if we're using machine learning. We can learn biases from other systems. We can be basically fighting the people that is doing user experience if we're working on monetization, and vice versa. So the key problem here is a non-technical question, it's a societal question, that if you have an algorithm, any algorithm, a particular search system, and you have a biased data, there is no such concept of really unbiased data. In practice, you will have some bias and could be positive. We have a negative bias when we talk to bias. And then the question is, should be the system neutral or should be fair? And most of the time, people don't worry about this question, and then they have the same bias, and even worse, the system may amplify the bias, and then in that case, the fault is not only in the data, it's also on the algorithm. And we will see that in particular, the interaction is one of the culprits of this amplification. Just to remember what is being fair, there are many of these cartoons in the web. You can look for them, but just to remind the difference between equality, equity, and justice. So we would like to have justice, but usually we can only do equity because justice takes too long to get. So in practice, you get the same bias, but the answer is that not always you need to worry, but you need to worry if this harms people. And in search, there are cases where we are harming people indirectly. And for example, legal cases may be a good example. How you solve this problem? Well, you can devise the input, tune the algorithm, for example, the machine learning model, devise the output, which is the simplest one, but of course it's too late because you already lost a lot of information. And we are not covering these techniques, but I will mention some examples later. This talk, on the other hand, is about bias awareness, because many of the biases we will show are not the typical ones that you see in the news, like gender or race bias. So let's see what is the cycle, the vicious cycle of bias. So you have, of course, the web, The first one will be data bias, the main one today. Uh, a very important one in the web is the web spam. I'm not talking about that. We all of us know this very well, or we should. But for example, you can have things that are more subtle, like gender bias in content. And this was a famous paper published 4 years ago in Europe, and where they tried to find she/he analogies, and they found some that were correct, like sister brother or mother father, queen king, but most of the others had some stereotype, like if she was a nurse, he was a surgeon, or if he was a superstar, she was a diva, and we know that there are some negative connotations to being a diva. Of course, the most probably all journalists in the US, most journalists, important journalists are men. I did some research, and the answer is yes. But also, I found that it's even worse because at college, most journalist students are women. So there's another problem with bias here on how to get a job. The next element of bias is us as users and the group. So not each of one of us, but the group. And has to do with activity or engagement bias, and has to do with the well-known long tail of behavior. So there are few people that do a lot, and there are many that do a little. And most of them just look, they don't interact. And we'll get back to that. Let's remind that in a paper we did at Yahoo Labs, uh, we show that we are all in the long tail. So basically, it's not like we are normal or we are weird. We have different states of mind, and sometimes we do things that are specific to us, and other times we do things that are normal to many people. And this is very important, for example, with popularity bias. This is more relevant in recommender system, but it's also true in ranking. So I just put this nice slide from Pablo Castells just to so you can see that basically people could be very different, people could be identical, and in that case, personalization is useless. But the truth is that we're in the middle. So we are in the long tail case, and that's why it's difficult. So in a few years ago, 5 years ago, with one of my PhD students, we looked at a problem related to content that was how many people produce half of the content. And we look at four large data sets, one from Facebook, where we found that 7% of the people did half of the post. Then we look at Amazon reviews. Then we found that 4% of the people did half of the reviews. So we were like, hard to believe that. We revised the result and it was fine. And I don't know if there is any causality, but 1 month later than we published this paper, Amazon started to sue fake reviewers, and this continues until today, because this is a big problem, and this is what I call social bias. I will mention this later, and of course, it's an example of web spam. Now, this is related to something Nielsen mentioned 14 years ago, which is the rule of internet participation, where he said that 1% of the people were the active persons, 9% were basically reacting to that content, and 90% was just looking. There were lurkers. We checked also a very large Twitter data set, and we found that 2% of the people did half of the content. So this 1% here is even worse, because here we are only looking at the active participants. So if we take 2% of 10%, this is like more like 0.2%, so much lower. In Wikipedia, it's even worse. All the data from Wikipedia usage is public. Basically, 2,000 people wrote the first half of English Wikipedia, and of course they were paid, but maybe that they made the difference because nobody will contribute to something that is empty. You need to have it at least half full if you're an optimist. So the next one is now that when we use the web and we build a search or a recommender system, we do some sampling of data. The sample may be biased, but the worst part here is the size of the sample. Many times we don't take enough data. And then we can have algorithmic bias. So for me, algorithmic bias is not the bias from the data, it's additional bias coming from the algorithm. And you will see that in the interaction, the algorithm can add bias. There are other examples, but they are not relevant to search, so I'm not mentioning it here. So the first one is sample size. So sorry, this is the only technical slide that I have more technical. But basically, what I want to show is that a typical error formula, let's say for a binomial event like a click, is basically diverges in very low probabilities, so very close to zero. So we cannot use that formula because we will basically use a smaller sample. For example, here I have an example for a probability that happens that we think that is 1/10 of the time with a very weak confidence interval of 80% and with relative error of 10%, then the normal formula will give 900 data points, but in the truth, you need at least 2300. Now, if you put a smaller probability like a real click, this will get much, much worse. And what happens is that when we do sample of very skewed distribution like query logs, then what you get is not what we want. For example, here is a real distribution of queries, and if we get too small, for example, this distribution of 1,000 queries doesn't really follow the right distribution. So you need to work with this, and I have a paper in CIR 2015 that basically I propose a stratified sampling scheme which works differently in the tail because the tail is very long, so such that we can get exactly the same shape in the query distribution. Now, related to this, there is also what is called accessibility bias by Lipani and other authors that basically is why we are not seeing a document. And I guess for Jeremy, this is very important if you want to get a high recall. And one measure of accessibility is called retrievability. That is the likelihood of a document to be retrieved by a search engine. Here you have the definition, and you can compute this. And in this paper in 2015, Lipani et al. Show that this really is a problem, and they have many causes. So first, you need to have the document crawl, and then you need to have the document really indexed properly, and so on. So let's go to the worst part of the bias is in the user interaction. And I will call this class interaction biases. There are many of them. And of course, it's not only a problem of the system, it's also a problem of the users. So here is where the cognitive bias of the users starts to work. And I will call this self-selection bias because for every person will have a different selection bias. So to understand what I mean, please read carefully the next slide. I don't know if you had time to read the bottom line, because people really read in the order that I want. So this is what I love. So this is the bias in the interaction. For example, in the Western world, and this is of course a bias example because my IR book is here on the first position, is that people look at the top left corner in the Western world because we read this way. We read left to right, top to bottom. So we look here. But the first bias is not where we look, is the things that we cannot see. So this is the main bias today. It's called exposure representation bias. And it's you can see, okay, it's like the typical iceberg example. The truth is no, because here we are seeing 8 books, and I'm sure there are many, many more, hundreds of books that are maybe relevant. So what we are seeing is just the ice cube on the top of the iceberg, and the rest is invisible to us. So this is the first thing here. Then we have the position bias problem, and one of the instances of that is ranking bias. People believe that the position number 1 is the best one. So rank number 1 is the best one. So you click in the first, the second, the third, and then this is very different. We have social bias. Some people may decide based on the stars, and we see that in the case of Amazon and other e-commerce sites, this is maybe false. And then we have other type of interaction biases, like do we scroll, do we move the mouse, do we click? And this is a cascade of biases, which part of the issue comes from the algorithm in the left, but the rest comes from the user, part of the self-selection bias if we click on the top positions, if we have to click very fast, if we have to move the mouse, or if we know how to scroll or not. For example, Mediative did several studies using eye tracking and showing this in a heat map, where you see how the position bias have changed with the change of the interface. Like this was a standard traditional text interface where we do look at the top left corner, while for universal search, we see that we look also at images. So when we put this in a real graph, and this is a real distribution, you see that number one is very high. So the percentage of clicks number one is very high. One reason is that here we have all the navigational queries, part of the law of minimal effort. People prefer to search something instead of putting the full URL, even though that they know it. But if you take this out, that is about 15%, you still have a lot of clicks on the first position. And also here you have an example of interaction bias, where because of some engineer in the first search engine, homework, which is the first search engine, is not Alta Vista, people don't look at the second page, while this is irrelevant now in mobile because it's a continuous answer. But in desktop, still we have 10 by 10, I don't know why. So if we could put this in a log-log graph, sorry, in a semi-log graph, we will see something like this. So we have these different pages, and what we like to find is the real distribution if we don't have this ranking bias and we don't have this interaction bias. And at Yahoo Labs, there were 3 papers published on this, the only public papers on how to basically de-bias clicks. Then other people work on learning to run with bias, like Jokins et al. In Cornell. And we have worked also in fair rankings, and we are doing new versions of this work. And I just put this reference because this is a case of the bias, the input. Here is tuning the algorithm, and this one is the bias, the output. And we can go to what is a fair ranking, just to people know. Basically, this will be important, for example, in LinkedIn search. We would like to have a minimum proportion of women in the search. And if you do the bias on the output, maybe we don't have enough women to put them in the right place because they're already filtered by the algorithm. So this is an example, and there are many ways to define what is the fair ranking. This is one of the typical ones, where we have one protected group, which is female, and a non-protected group, which is male. So that was just to understand what is fairness in the concept, in the context of search. So let's finish the cycle. So this is what I call second order bias. People use the content of search for different tasks. So the first one is that you put content back into the web. And this was maybe the first paper I did in bias, but I didn't know I was doing really bias. I was looking at something that I felt was wrong, in the sense that was not good for search. And the problem is it still exists because it's very hard to solve. So let's say you're writing a new blog page, personal blog page, and you do some query that is associated to the topic of the new page, and you choose 3 pieces of text that are interesting. So you are doing a mashup of opinions. Of course, here you already have ranking bias because you are choosing this from the top results, and then you put them in the web page. Of course, you are not doing plagiarism, so you will put a link back to the original content. You will put quotes here, and you will mention the author's name. Those 3 things are the main difference between plagiarism and research. Of course, you feel some shame because there's nothing yours, so you put some content that puts everything together. And of course, ego kicks, and you put your name on the top and a nice title because this is not your page, although most of the content doesn't come from you. And you publish this in the web. What is the problem here? Well, the problem here is that this content is biased to whatever ranking function the search engine believes is good. And if you're putting back that into the web, you're reinforcing the belief that that is the right ranking function. And this also grows the semantic redundancy, and we show in this paper in 12 years ago in that basically the redundancy may be 35%, and 12 years later may be much higher than that, especially in the most popular pages. The other possibility with the interaction is that your data go back to the system to be used to optimize the system, what I mentioned at the beginning. And here is when we have the really the feedback loop bias, which is very negative. And the first one is, of course, personalization, partially the effect of self-selection bias, and this creates the filter bubbles. I don't know if you have read the book, already 9 years old, of Eddie Pariser, but surely most people have seen this movie, The Truman Show, and basically he was very happy until he found that he was living in a bubble. And of course, he was one of the persons that wanted to get out of the bubble, and that's part of the movie. But many people don't realize that you're in a bubble, and even if you realize that, they are happy with like that. And many elections show that, although we have a nice change in the last US election. So what are the solutions that search engines are using to avoid this? One is diversity, of course, novelty, serendipity, but I would like to have something even more weird that I call my dark side. For example, I would like to have a ranking where will be, give me the ranking of the most different person to me. For example, if I'm looking at news, not because I want to see the news that that person is looking, maybe fake news, because I want to see how far I am from that person. Because today we have the wrong perception that people is similar, more similar than other people that we think. And for example, in the UK, the European Union opinion will be a good example of how different people can think. And there's a problem here about explore and exploit and another thing, but that is something that I'm doing research these days. But also, if people is in a filter bubble, then you can think that systems are also in a large filter bubble. You can think that the filter bubble of the system is the sums of all the filter bubbles of people, because the system is writing its own future because of exposure bias, because of the things you can click on. So popularity bias is one example of this echo chamber. And if we don't do enough exploration, basically we have a partial knowledge of the world. And that's a problem because then we have a suboptimal solution in the ranking. This is worse in recommended system, but imagine how many new pages appear every day. Do they get the right exposure? And do we find out which queries are really good for those pages or not? I'm sure surely the answer is no. There are more than 100 billion web pages today. So the last one has to do with ourselves. So we are in this system, and for example, great that Jeremy talked about this, because we are neglecting small data. In most search problems, we don't have enough data. In most problems, machine learning doesn't have enough data because most companies in the world will never have big data. So small data is much more frequent and harder. We should work more in small data, not only on search, in many other problems. What about the design and implementation? There are experiments that show that system reflects the characteristics of the designer. That system reflects the characteristics of the coders. And that's why we need to contest the designs and the assumptions very early on the implementation to avoid biases later on. We also have biases on the evaluation, choosing the right experiment, choosing the right test data. For example, here you have a problem of pool bias in test collections, also work of Lipani et al. Choose the right metrics, choose the right baselines. For the people that do research, how many papers, some work has been rejected because we didn't have the right baseline. And here, Julio Gonzalo has an excellent talk in ECCIR last year, so I suggest that you can check that one. So I have a opinion paper in KD Nuggets about small data, and also there you can see this very interesting experiment about data analytics with crowdsourcing of University of Virginia in 2015 for the design and implementation part. So what we can do, just to finish, so not only show the problem, but show what we can do. So for example, with data, we have to analyze for known and unknown biases. You need to debias mitigate when possible needed. You can recollect more data for sparse regions of the problem, so to avoid basically that you have an error bias. And of course, if you have attributes associated directly, indirectly with harmful bias, like for example, address of a person, so on, you need to basically remove them. Even if you remove them, the system can learn this bias, like the famous example from New York Bales, where the system used only the age of the people and still learn how to be racist and more racist than the judges. So bias is really encoded intrinsically in data. In the interaction, make sure that the user is aware of the biases all the time and give more control to the user. The user, in many cases, especially, for example, if you see e-discovery, the user is smart, is looking for things, give more tools to that user. Design and implementation, well, as I said before, contest every step of the process, contest every assumption, check with real users early in the system, in the design of the system, and so on. And finally, evaluation, basically do not fool yourself. The only one that will be harmed is yourself. Just to make sure that it's not also everything is negative, remember that web works thanks to bias. Caching is an effect of bias. And even search changes are very important, like answer caching will answer 20 to 30% of the queries. So it's very powerful to have a fasted answer time. And also there are some web pages that are essential, as this paper 5 years ago that where we show with Paolo and Flavio that basically 25% of the queries can be answered with less than 1% of the URLs. And then the same happens in e-commerce. So this is because of activity or engagement bias and self-selection bias. So to end, the take-home messages is that we need to be aware of our own biases. That's the first way that solving the problem starts. And particularly also the biases we put in our systems. And we have to stop this vicious bias cycle. And there are plenty of research problems if someone wants to do like a PhD thesis here. So here I have another example of bias, a bias ad. There are two conferences that started more than 2 years ago in these problems. And also Wisdom has a track that is interested in these kind of issues. And I think I have some time for questions. I can take also bias questions, but then you may get bias answers. So thank you.
Yeah, great talk, Rick. Thanks, really enjoyed it. I'm just wondering, I mean, I think we all subscribe to the view, you know, that in principle, everything you talked about, minimizing bias makes total sense. I'm just wondering whether how pragmatic the end goal actually is, in the sense of having the vision of a truly bias-free, let's say, web search engine. Let's make it really hard. Is it your view that it is possible to design, build, and deploy a large-scale bias-free web search, let's say, web search engine, or do you think it's more just it's something that we just constantly have to manage and mitigate and measure?
Yeah, yeah. Good question. Is I think the answer is no. We cannot have a bias-free system, but of course we shouldn't have a non-aware bias system, because that can go anyway. So basically we need to work, it's like web spam. We need to be mitigating and managing web spam all the time. The same happens with bias. So at least we are going in the right direction. So for example, will be like, we need to take affirmative actions like in gender bias. So, because otherwise we don't have justice. And remember that here in search, we have also adversarial opponents that basically are trying to deceive you with web spam. This could be seen like an adversarial bias, but there are many others that are intrinsic to society that are encoded there, like we said already, gender, race, sexual orientation, even economic situation. This happens more in justice and in other applications, but also in search is important. There are many examples of where, for example, even search engine optimization is affecting choices of people. And there's a paper that was published, I think, in Proceedings of National Academy of Science in 2015 about what they call SEME, so the search engine meme. So basically how these things affect choices of people, and then this affects, for example, elections. So we need to work on this, yes.
Yeah, thanks.
Okay, we have some questions now coming in the chat window. One from Habib: can bias be considered a positive attribute at any point?
Yes, I mean, as I said in my presentation, bias, we have a negative connotation for bias, but bias can be positive. So every affirmative action we take is a positive bias towards the right solution. I see that Brunella took my comments like as a way that I'm happy with the situation. No, I'm not happy at all. I don't accept that there isn't a solution, but I'm realistic. I know how difficult is to build like a web scale search engine, and that was Tony's question. It will be different, we say, if we have a very focused search problem and we try to get rid of bias there, the answer may be different. Yes, maybe we can get almost a free bias search system, but in a system that is growing every day, like the web, in users and content, is much harder. It's like it's like Alice in the mirror. So she's running, but it's only running to be at the same speed of the queen.
Okay, then I think another interesting question, your opinion about should we spend more effort into debiasing or more into bias awareness, so meaning embracing the bias?
I think both are important. So the first one is awareness, because if we're not aware, we cannot solve the problem. So this is the number one step. And typically, for example, if you want to get out of your filter bubble, the first thing is you need to be aware of you are in a filter bubble. And this is in a list of things I'm preparing for the filter bubble. Nice to see Edgar here. But of course, we need to mitigate. The one problem is what is exactly how much we need to mitigate. So for example, in the case of, I mentioned, there are many cases I don't know what is the reference value. For example, you can go to a university in India, and 70% of computer science students are female. The same in Iran. So there is the positive case of, say, the UK. What is the right number? I don't know. Maybe in nursery we want more women. So one problem with bias mitigation is that we don't have all the time the reference value. We don't know what is the right number. And in many cases, the number is not up to us. It's a societal decision that is changing all the time. So depending on the country, for example, maybe a Buddhist search engine is different from a capitalist search engine. Surely it is. I don't know how, but these things are not being studied. We're still beginning on bias on AI, trying to see how philosophy and ethics applies to these systems.
Okay, there are some other questions from, they're coming now, the questions, wow. I don't know if you can see the questions yourself, Ricardo?
I can see the questions, so I can see them, so let's see.
So maybe Dave Newman had one?
Yes, should one actually declare the conflict between a bias in your data selection when you limit in the number of results at which you stop sifting the results? Yes. So for example, every time you set a threshold, you are creating arbitrary technical bias. I hate thresholds. When say, okay, let's say 50%, 40%. Well, what about the next person or the next result that is after that threshold? You are being unfair with that result, especially if the difference in the long tail of ranking are almost zero. And of course, the error that you have in the ranking in the long tail is much larger than the difference between two scores. So you are being unfair there. So I can go on about the long tail, because the long tail is the place where you have more unfair things, especially in e-commerce, but in ranking also happens the same. So there's another comment from Sami that says, if a system is powerful enough, it starts training us with its bias. There seems to be an idea to use this system to train the users to be less biased. Do you think this is a good idea, moderation? Oh, tough question. I think we need some moderation, because then people can say whatever they want and they shouldn't in social media. Maybe the moderation is not to censor that, but just to say that, like some systems do, like Twitter, that this may be false. So to warn people. So I would say I would like to have like a false score or a bias score in every object that you see in the web, so we can at least take our own decision. Maybe this is false, maybe this is deceiving. But we do have some training in many ways. For example, do people use two words to search because the system is good, or because the system taught us to search with two words? Or really it's a loop where we cannot get out because we have the two things working at the same time, which is what I believe, if both things are true. And so all these things are encoded in our system. So the question is, can we at least be aware of these things when we design the systems? For example, when decide we have 10 answers in a page, this is a silly choice. So for example, okay, let's have the size, the number of things that fits the page, or maybe have a continuous thing. Can we do things, for example, like randomize results a little bit in rankings so we can get a fair amount of clicks and so on? There are many solutions that can be done, but they are not tried today. So Nigel says search engine is an equal association engine, like human memory bias pruning, equal memory pruning. Yes, in some sense, yes, and remember, relevance works like this. If you see something that you already know, it's not relevant, right? So